Today's notes are going to be an introduction to the modern atomic model. We're going to look at how electrons are housed, or how electrons fill the orbitals of the electron cloud. So electrons travel in distinct regions of energy called energy levels. And the idea behind the modern atomic theory is that we're really just predicting the most probable location of our electrons, and that we don't know exactly where the electrons are. So again, one cannot know the exact location of electron. We can only determine or know the most probable location of the electron. So our goal for this is to determine or describe the most probable location of electron for an atom or ion. So again, we're just looking at where is the most probable location of our electrons in an atom. And again, that's based off of that idea that electrons behave like a wave. So the first thing we're going to do is we're going to use that same analogy as we did in class. So we're going to pretend that we have borders, and our borders are the electrons. And in our boarding house, we only had 3 floors, and there were sunny rooms, and there were pink rooms, and then there were bunk beds in those rooms. The sunny room only had 1 bunk bed, whereas the pink room had 3 bunk beds. Oh, I drew 4. 1, 2, 3, 4. I drew 4 floors. Now, the reality is, for electrons, there are a lot more than 4 floors. There are 7 floors in this fictitious boarding house. And there are more types of rooms. So there's also a dark room. We're going to say that that room has 5 bunk beds in it. And there is a floral room as well. And those have 1, 2, 3, 4, 5, 6, 7 bunk beds in them. So our boarding house is actually quite large. Now, in our analogy, we had floors. So if we were going to describe where a guest or a boarder was, you could describe what floor they're on. You could describe what type of room they are in. You could also describe the bunk bed that they are in. And then once you figure out the floor, type of room, bunk bed, at that point, hopefully you have found your actual boarder or your guest. All right. So all of these are sort of analogous to our electrons and the electron cloud. So the floor is synonymous to our energy level. And normally when we talk about our energy levels, that's represented by this letter N. So you'll see when N is equal to 1, that means that we are on the first energy level. If N is equal to 2, that means that we are on the second energy level, and that's a lot like the floors. And that's really about how far away each level is from the nucleus. So the first energy level is the closest to the nucleus, the second energy level is further away, the third energy level is even further away from the nucleus. And these floors or energy levels are distinct in their energy, so each one has more energy than the next. And they do correspond to the periods on the periodic table. So you'll notice that there are 7 periods if you count down the periodic table. There's, if you're counting down vertically, there are 7 actual rows as you count down, and each of those is a period, and each of those correspond to an energy level. So that is synonymous to your floor. Now, our next analogy, once we know what floor or energy level we're on, we can also figure out what type of room we're in. That's synonymous with the idea of sublevel. So each floor has certain sublevels on it. So floor 1 only has S, only has the sunny room. The second floor or the second energy level, you'll notice, had the sunny room, but also had a pink room. Now, once you get up to the third floor actually has those additional rooms. So they have a sunny room, a pink room. There's also the dark room, or there is a D sublevel that actually has 5 orbitals in it, or 5 bunk beds. And the last one is, by the time we get up to the 4th floor, there are actually 4 types of rooms. There's going to be a sunny room, a pink room, a dark room, but there's also going to be that floral room, or an F sublevel. And that F sublevel has 7 bunk beds in it, or 7 orbitals. I want to mention down here, all electrons within a sublevel and in the same N will have the same amount of energy. So here's your example. All electrons in the S sublevel on the first floor have the same amount of energy. Or if you want to think about it, if you're on the second floor and you're in the P sublevel, remember there are 3 bunk beds there, they all have the same amount of energy. All right. Onwards to our bunk beds. So different rooms have different numbers of bunk beds. But our bunk beds are synonymous with the idea of orbitals. Now, orbitals, this is our most probable location for an electron. That we can narrow it down to, it is probably in this particular orbital. Now, that's like saying that your guess is probably in that bunk bed, on that floor, in that type of room. Now, all orbitals, like the bunk beds, can hold a max of 2 electrons in it. The last part is that once we know where our electron is, that was synonymous with the guessed. And our electrons that are in the same orbital or in the same bunk bed must be spinning in opposite directions. So our electron was synonymous with our guessed. We can narrow it down to its most likely orbital, which tells us also what sublevel and energy level it is on. All right, so that was our analogy. So we're going to move on to how do we know where our electrons are, what are the rules, what are the filling orders, where is the most probable location of this electron. Now, one of the things you have to start to do is be able to picture some of these orbitals, and we'll look at more videos during class. But your S sublevel is made up of just one orbital. It tends to have this sort of spherical shape, and it can hold 2 electrons maximum. Now your P sublevel, like we mentioned before, has 3 bunk beds in it, or 3 orbitals. But again, they're not actually bunk beds because they're electrons, and they're actually these regions of space in which we think the electron is in. And so for the P sublevel, the regions of space look kind of like this, like these little barbell looking things, and each one is on a different axis. So they're all 3D. One is on the x-axis, one is on the y-axis, and one is on the z-axis because it's 3-dimensional and it's coming out towards you. Now, because there are 3 orbitals and every orbital holds a max of 2 electrons, if I have 3 of them, that means that the P sublevel can hold 6 electrons. Now, the D sublevel actually has 5 orbitals or 5 bunk beds in it. And they do have these sort of other clover-like shapes. The shapes actually start to get quite complicated after the P sublevel. But the D sublevel look kind of like clovers. And again, there's one on like the x-axis, one on the y-axis, one that's like tilted on the z-axis in one direction. And they're each sort of trying to avoid each other because the electrons repel one another. But there are 5 of them. So there are 5 of these sort of clover-esque shaped orbitals. And again, since every one orbital can hold 2 electrons, that means on the D sublevel, it can hold a total of 10 electrons. The F sublevel, again, the shapes get real weird, but there are seven like possible regions of space, and they do have these very like they look like barbells with little hula hoops sometimes, but there are 7 of them. So there are 7 of these different regions of space that exist on the F sublevel. So there are 7 orbitals or 7 bunk beds, and again, if each orbital can contain 2 electrons, that means that you have a max of 14 electrons that you can hold on the F sublevel. All right. Whew. So moving forward, we have different floors that have different types of rooms. So the S sublevel has 1 orbital or 1 bunk bed. The P sublevel has 3 bunk beds. The D sublevel has 5 bunk beds. The F sublevel has 7 bunk beds. Now each floor has different types of rooms on it. Just like our analogy, the first floor only has 1 type of room. It only has the S sunny room. Now, that means that it only has 1 orbital that exists there. That means there's a total of only 1 orbital on that whole floor. And that means that whole floor can only hold 2 electrons. And this holds very true to our analogy. So if energy level is your floor, and this is your type of room, and this is your orbitals is your number of bunk beds, and your total number of orbitals is your total number of bunk beds on that floor. And then this is basically how many guests can that floor hold. If I look back up at my picture, I can see that the first floor here only has the sunny room. There's only 1 bunk bed on the whole floor, and it can only hold 2 guests. The second floor, so if I move up to my next floor, the second floor actually had a sunny room and a pink room, or an S sublevel and a P sublevel. Now the sunny room only has the 1 bunk bed in it. That's what makes it the sunny room. The P sublevel actually has 3 bunk beds in it, or 3 orbitals. So those 3 different barbell shapes exist on the P sublevel. That means on that floor, or on that energy level, I have 4 total orbitals that exist, and that means on the second floor I could hold a total of 8 electrons, or 8 guests. So again, if I look at my picture, I can see that's true. I've got on my second floor, I've got a sunny room with 1 bunk bed. I've got a pink room with 3 bunk beds. That gives me a total of 4 bunk beds here, and that means that I could fit 8 guests on my second floor, or 8 electrons. So now our analogy starts to get a little bit more complicated, because my third floor has the sunny room, it has a pink room, but it also has a dark room that I did not depict in the analogy, mostly because it gets a little bit complicated. But the sunny room still only has 1 bunk bed in it. The pink room has 3 bunk beds in it, or 3 orbitals. The D sublevel has 5 bunk beds in it, or 5 of these little clover-shaped clouds that can exist where my electrons can exist. So that means that I have a total of 9 bunk beds on the third floor, and 9 orbitals that exist on the third energy level, and that means that it can hold a total of 18 electrons. Then we get to our fourth floor, and it gets even more fun. You have a sunny room, a pink room, a dark room, and now you have an F sublevel. We call it our floral room. So our sunny room still has 1 bunk bed in it. Our pink room has 3 bunk beds. Our dark room has 5 bunk beds, and our floral room has 7 bunk beds. That gives me a total of 16 bunk beds on the 4th floor. That floor can hold 32 electrons. The 5th floor, thank goodness, looks a lot like the 4th floor, so there are no additional types of room. You have the sunny sublevel, the pink, the dark, and the floral. So the S sublevel only ever has 1 orbital. The pink sublevel has those 3 different orbitals, those 3 barbells that are at different angles. There is the D sublevel that has all those clover shapes at different levels, and they have 5 of those clover shapes. And then the F sublevel has 7 different orbitals of various shapes you'll see in the video. And that gives us a total of 16 orbitals. If every one orbital holds 2 electrons, that means you can fit 32 electrons on the 5th energy level. The 6th energy level ends up only having a S, P, and D sublevels. So the S sublevel holds 1 orbital, has 1 orbital in it. The P sublevel has 3. The D sublevel has 5. And that gives us a total of 9 orbitals on the 6th floor. So many floors. And that means I can hold a total of 18 electrons. Our last floor only has an S and P. It looks a lot like the 2nd floor, but it's further away from the nucleus because it's the 7th energy level. The S sublevel only has 1 orbital. The P sublevel has 3 orbitals. That gives you a total of 4 orbitals on the 7th floor. And that means that on the 7th energy level, it can hold a max of 8 electrons. All right. So in your analogy, there was a certain order to filling. You would fill the 1st floor first, and then the 2nd floor, and then the 3rd floor. You would fill the S room, and then after you filled the S room, then you would fill a P room. So there was a certain order to how you were allowed to put your guests into the rooms. Now that still holds true here, but the order gets a little bit complicated. So we always fill based off of Aufbau's principle. The ground state of an atom or ion, your electrons fill orbitals at the lowest available energy levels before occupying higher levels. So we always fill the lowest energy orbitals first and then move to higher energy orbitals after that. And that really has to do with the distance from the nucleus. So things that are closer to the nucleus have less energy, and things that are further away from the nucleus have more energy. So we fill from low to high. That is the rule. So down here is low energy, and up here is high energy, and you will see that the further away from the nucleus you are, because here is our nucleus, the further you are away from the nucleus, the higher your energy. All right, so as we predict, energy level 1 is typically closer to the nucleus. Energy level 2 is a little bit further away. Energy level 3 further, 4th, 5th, 6th, and 7th. So we typically fill energy level 1 first, then energy level 2, then energy level 3, then 4, then 5, then 6, then 7. But it gets oddly complicated when you start to incorporate some of those dark rooms and floral rooms, and it actually starts to get a little bit trickier. So if you look over here, this gives you the actual order of energy for each of the different sublevels. Now, 1S, that first sunny room, has the least amount of energy. And then we would start to fill the 2nd energy level, so the 2nd floor sunny room and the 2nd floor pink room, just as we were doing before. And then the 3rd floor sunny room, and then the 3rd floor pink room. And then this is where it gets a little bit tricky. The dark rooms, because of the shape that the electrons take when they're in their wave function and on this particular sublevel, it actually has a higher energy than the electrons at 4s. So what ends up happening is that electrons will fill the 1s orbital, and then the 2s, and then the 2p, and then the 3s, 3p, and then they'll fill up 4s and then go to 3d. And then electrons will fill 4p and then 5s, 4d, and then 5p, and then 6s, and then 4f, because that f gets even extra trickier. And then 5D, 6P, 7S, 5F, 6D, 7P. So this ends up being the actual filling order, and these are already arranged from lowest energy level to highest energy level, and it does get a little bit tricky once we start hitting the 4th energy level. Now, nobody's going to ask you to memorize this filling order, but I will show you some tricks as to how to figure out your filling order in a way that's a little bit easier. But just so that we are very clear here, the filling order for our electrons, if we're going from increasing from low energy to high energy, this is how you should be filling your electrons. Electrons will first go into 1s, and that can fit 2. Then you would fill 2s, and that can fit 2. And then you would fill 2p, and that fits 6. And then it would be 3s, and then you would put electrons into 3p. And then this is again where it gets tricky. You go to 4s. All your s sublevels fit 2 electrons. And then you would fill 3d. Blech. Now D has 5 bunk beds in it, so it fits 10 electrons. Then you would fill 4p. P has 3 bunk beds, so it can fit 6 electrons. Then you would move on to 5s. And then you would move on again. It gets a little bit tricky here. We go on to 4d. And then it'll be 5p. And then from there we'll go 6s. Oh, and then we start entering our floral rooms, so it's going to be 4f. Your floral rooms have 7 bunk beds in them, so it can hold a total of 14 electrons. And then we go to 5d, and then we would fill in 6p, and then we've got just a few more. 7s, your sunny rooms again only hold 2 electrons, and then it's going to be your 5f, your 5th floor floral room, and then it'll be 6d, and then 7p. So this is the order in which you would put your electrons into each of the clouds, or this is the order in which they fill each of the clouds, because they fill from low energy to high energy. All right, so then how do we use this? So I'm going to use arsenic as an example. And if I look at arsenic on the periodic table, I can see that it is atomic number 33, which means it has 33 protons, and if I'm assuming arsenic is neutral, it also has 33 electrons. So let's say we're using our analogy and we have to house 33 electrons, or 33 guests. The idea is, where are all of these 33 guests at? What is their most probable location based off of our filling order, which is based off of the energy of each sublevel? So when I'm looking at arsenic, I can see that the first place that I would put my guests is in 1s. And 1s will fit 2 electrons. So I've got 33 to house. So far I've put 2 of them into a room. Then I can put electrons into 2s. And then 2p comes next, and that holds up to 6 of them. And then I could put electrons into 3s, and then 3p. Now I'm going to stop here and just count up how many electrons I've housed. I've housed 1, 2, 3, 4, 10, 11, 12, 18. I've only housed 18 electrons, and I have to house 33 of them. So I'm going to keep going. Then I'm going to put some electrons into 4s, and I can put 2 of them in there. And then 3d comes next, and I can put 10 in there. So now I'm going to count them up. I had 18 here, so 19, 20. That's 30. So now I've housed a total of 30 electrons if I look at all those numbers. And I need to house 33 of them. So after 3d, I can start putting electrons into 4p, 4th floor pink room, if that's how you like to think about it. And I've got 3 more electrons that I need to house, because I need to house 33 of them. So I can put 3 of them into that pink room. So then this ends up being my electron configuration, or my manager's code for arsenic and all of its electrons. So this is the most probable location of the electrons in arsenic. So if I look at it, you have to double check and make sure that you've got 33 electrons accounted for. So if I count up all my electrons, it's 1, 2, 3, 4, plus 6 is 10, 11, 12, 18, 20, 30, 33. So I've got 33 electrons housed. This is the electron configuration for arsenic. This is just one way to depict where my electrons are. The other way is by doing what we call an orbital diagram or an orbital box diagram. Now, I don't use boxes mostly because I'm lazy and I don't want to draw boxes. So what I typically do is I rewrite the electron configuration. So it's 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d10, 4p3. So that was the electron configuration for arsenic. Instead of drawing boxes, I draw lines. So the S sublevel has one bunk bed. So for all the S's, I draw one line to represent that one bunk bed. You don't have to color code yours. I'm just going to do it to try to be helpful. Your P sublevels have 3 bunk beds in them. So there are 3 orbitals. So 1, 2, 3. So I'm going to draw 3 lines to depict those 3 bunk beds. 3P also has 1, 2, 3 bunk beds in it. And then 4P also has 1, 2, 3 bunk beds in it. And then your dark room had 5 bunk beds in it, or 5 orbitals are in your D sublevel. So it's going to be 1, 2, 3, 4, 5. So again, I draw lines, underlines, instead of boxes. You can draw them as boxes if you'd like. So the next thing I need to do is I need to put my guests or my electrons into the boxes. So I see that I have 2 electrons in my bunk bed. So I'm going to put 1 electron in, and then I'm going to put my other electron in. So those are my 2 electrons. They do have to spin in opposite directions. That is Pauli's exclusion principle. So 2 electrons in the same orbital will have opposite spins. I'm going to do the same thing for 2s. I'm going to get lazy with my electrons, and I draw my arrows just one-sided. So for 2s, I see that there are 2 electrons in it. So 1 will be spinning up and 1 will be spinning down because there's only 1 bunk bed, so they have to share that bunk bed. For 2p6, I'm going to put, due to Hund's rule, every orbital in a sublevel must be occupied by 1 electron before any orbital is filled with the second. So when I'm looking at 2p6, I see that there are 3 orbitals, or 3 bunk beds, and I've got 6 electrons. So it's going to be 1, 2, 3. I'm going to fill each one first, and then they start to double up, 4, 5, 6. So that's what each of those orbitals look like. 3s has 2 electrons in it, and there's only 1 bunk bed. 3p has 3 bunk beds, and we've got 6 electrons. So 1, 2, 3, 4, 5, 6. 4s is 1 bunk bed. It's got 2 electrons in it, so it goes 1, 2. 3d has 10 electrons, but there are 5 bunk beds because the D dark rooms have 5 bunk beds in them. So it's going to be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And the last place that I would find my electrons if this were a ground state atom is in 4p. Now your P sublevel has 3 bunk beds, 1, 2, 3. And I've got only 3 electrons here because remember I only housed 33 electrons. So I'm going to go 1, 2, 3. And I am following Hund's rule here. It's really obvious because I put an electron into each orbital before I would start to put in a second electron. So for this last orbital, it would never look like this. You can't leave one of these empty and double up one of the orbitals. So each orbital gets an electron before they would double up. So it's basically like you wouldn't share a bunk bed unless all of the bunk beds already had somebody in them. So this is what the orbital diagram would look like for something like arsenic. I'm going to delete all these little extra black lines down here. But this would be sort of a drawing of our orbital diagram. And our orbital diagrams give us more information. It shows us the spin on our electrons. It shows us each of our orbitals and how many electrons we would expect for those orbitals to have. So what you're going to do as additional practice is you're going to do the orbital diagrams and electron configuration for these additional problems. We're going to do these in class together, so you do not have to do them at home. I am going to go over a set of notes on the next video about how to use your periodic table in order to help you draw up your electron configurations maybe a little bit faster.